Hey everyone, in today's video we will discuss smart pointers. I will start with what it actually is, then cover cases you most likely will use it, and finally show how to use all types of smart pointers given by Qt framework in code. But what it actually is. In simple words, smart pointer is just a wrapper for a row pointer with the garbage collection. There is no single smart pointer type. As you see, we have many of them, but all of them try to abstract a row pointer in a practical way. A smart pointer, by comparison, defines a policy to when the object is destroyed. So still, you have to create the object, but you no longer have to worry about destroying it. Qt framework provides us a wonderful way to manage memory with the QObject relationships. And you're probably curious why we should use smart pointers. When your class inherits QObject, you most likely don't have to use them, because it is going to be overkill. But sometimes, when you develop Qt apps, you can eventually need to have a row class. That is not inherent in QObject. And this is the case for using smart pointers. So, okay, I want to start with shared pointers. Shared pointer, shared data pointer, and QExplicitlySharedDataPointer. Because it is not hard to understand, and you will see how in most cases smart pointer types differentiate. And also, the main purpose of those last two is to help shared ones. So you have to know it. Okay, let's start with QSharedPointer. And it is the most general of those three. You have here a lot of methods. I will show you an example. And it behaves exactly like a normal pointer for normal purposes, including respect for being constant. QSharedPointer will delete the pointer it is holding when it goes out of scope. Provided no other QSharedPointer pointer objects are referencing it. Or with simple words, it helps us share access to the same object and becomes deleted when it is out of scope. So let's write quickly a few lines of code as an example to start shaping your understanding of smart pointers. In this example, we'll create class with the constructor and destructor to see when they are called. So class, I will call it just my object with public section, my object as a constructor, and it's gonna be just, let's include qdebug, and also let's include QSharedPointer. I'm gonna be qdebug, and my object is created. And also let's copy and paste, just make it destructor when it destructs. When is destroy it. And I also, no, I don't want to make anything. Let's delete comments. In this episode, we're gonna have a lot of like small examples for all types of smart pointers. So I will make functions for it, and they will show the scope where pointers are located. And of course, all code I will write today is in the GitHub repository, link in the description below. Okay, wait, let's name it E1, then E2, E3, like example. Okay, and in this example, let's create QSharedPointer of type my object. You have to, if you know smart pointers from C++, then it won't be hard for you. You have to specify here in template type. And we provide new my object without any parameters, because only constructor we have is without parameters. And as I said, it can share access, so the second one is going to be also QPointer my object, and it's ptr2 equals to ptr1. Okay, but it's not pointer, it's like just object. No, and I make it in the scope this example one because I want you to see when an object destructs. Notice one thing: we make two variables, but with only one object. Here, if let's add new property QString, just QString, let's name A, doesn't matter really. And ptr1, we can access it with this operator, A equals to, I don't know, ABC. And then if I q debug A, but it from second one, we'll get the same. Here, if I call it E1, let's run. And as you see, object is only one, but we have two pointers. So it behaves like a pointer, it shares access, and that's how it works. And at the end, it destroys it. Under the hood, it stores reference count, and while it equals 0, delete an object. Most methods are self-explanatory inside, if we go here. But the most important ones are get and just data. Let me show you it here. Get and data. Just return value. Value is our row pointer. Just return it as constant. Then important one is clear. Here we have clear. It just drop in the reference, and maybe here we have reset. It calls just clear, but also have 3 overloads. So in the simplest case, it just calls clear. But it just resets smart pointer to point to another object. As you see, the simplest one just clears. And one more is swap, also important one. It swaps pointer to other instance. And notice that it marked as no except, and hence it's very fast. Okay. Next smart pointers will look pretty much the same inside, but will only add a new method or more overloads for old ones. All smart pointers are similar pretty much, but just add some new feature. The next pointer we'll talk about is QSharedDataPointer. Here we have it. If you compare that name to the previous one, notice the word data added. It probably means that it cares about data more or something. The main purpose of it is implicit sharing with the copy on write, or simply co rule. It means that whenever two smart pointers looking at the same object and first is changing, then copy will be made, and changes won't happen in a second one. In the next example, we'll make a separated object because it should inherit QSharedData. Let me show you what I mean. We can probably close it, or no, we can just copy them because class is similar, but I just want to show you difference. And it should, let's name it my shared object, for example, and also rename everything inside. And it should inherit QSharedData. We should inherit object for the classes that is used with the QSharedDataPointer and QExplicitlySharedDataPointer. it should be inherited. Okay, so let's make another function e2 and say that QShared, and of course we have to include everything, QSharedDataPointer. Shared data pointer, my shared object, Peter1, we pass here new my shared object, then let's say Peter1, that string is equals to ABC, then let's make two more pointers, and Peter2 gonna point to Peter1, and Peter3 is gonna look at Peter2. Okay, then let's try to change value in Peter2, and let's say a is equals to, I don't know, QE, just random characters on my keyboard. And then let's qdebug everything that we have. So Peter1 A, and then copy and paste second and third. Notice here, look careful, you know, we assign in the Peter1 A equals to ABC, then Peter2 is equals to Peter1, and Peter3 equals to Peter2. So they share the exact same object. So for now, they share the same object with A equals to ABC. But next, we assign Peter2 to A, to equals to QE. And then if we print it out, let's see, sorry, I didn't call it. Here I call E2. And then let's see what we got. QE. Oh, sorry, my bad. It's I just looked at it and it looked just strange. Here we should pass Q. Sorry, my bad. QSharedDataPointer. Yeah. Now let's look at what I mean to you. Here you see the second one is equals to QE, but first and third ABC. Why? Because as I said, the main purpose of the smart pointer is implicit sharing with copy on write. That thing is have simply a copy on write. If you ever saw call, it means copy on write. Okay, that rule. So here, when I changed value inside, it just made copy. And okay, now we will jump to the next one, and I will also notice how it do it, how it doing copy, and we don't know about it. And the next one from the shared category is QExplicitlySharedDataPointer. It is very similar to the previous one, but what means explicitly? Here we have explicitly. The thing is that whenever we change some property values in one of those two smart pointers, the touch method, we have here the touch method, and here we have the same in QSharedData, the same one. Method is called. As documentation said, if the shared data object's reference count is greater than 1, this function creates a deep copy of the shared data object and sets the pointer of this to the copy. What it means is that, I mean, here I read from here. So whatever we share data with more than one pointer and data is changed, then this method should be called. And when we do it with QSharedDataPointer, it makes it automatically. To see all of it in action, we'll write a bit bigger program with QExplicitlySharedDataPointer, and then quickly rewrite it to use the previous one, that one. So you will see the difference. And now let's create new class, but I don't want to separate methods to the source files and header files because methods will be really short. So I will write methods, method implementations in the header, just not spend time. Employee data. The first one I will name class employee data. And here let's include everything we need. QSharedData, include QString, because for the first one, this employee data is gonna be just a class to store employee data, and it will be QSharedData inherited. So QString, and also we will need probably QDebug, I think. Okay, class employee data inherited with QSharedData public. Then let's write constructor, and okay, before writing the constructor, real one, and it should be public, of course. I want to make properties. The first one will be ID, then QString, let's see, name. And here, the empty one, we will just specify ID as -1. And let's write message QDebug employee data is created. Then the second one, it will be copy constructor. So from the previous episode, you know that QObjects don't really have copy constructor, but here it is not QObject, so we can make our things. Okay, it's gonna be constant order, and just here we should pass everything in. First is QSharedData. We should pass to the QSharedData constructor this other. Then ID is other.id, and name is other name. So let's put it on the second line, and here also write a message. Maybe it's copied. And the last one is gonna be destructor. When we destruct, destroy our object, destroy it like this. And the next class we will create is actually gonna use this QExplicitlySharedDataPointer, smart pointer. I mean, names are long, it's hard. Employee, and here I will, let's create class without class not inherit anything, because there is class to like kind of manage the previous one we created. And here I want to include employee data, and here in public section, no, let's firstly in private create the main thing we here. It's explicitly QExplicitlySharedDataPointer with employee data and employee data. Name it just D. And then we can make all constructors and all those things. Here's D equals to new employee data, just like this. Then employee into ID. It's the case where we pass some data. Name, not pointer, sorry. Just link. And here we say D equals to new employee data. Then as to set ID, let's create another methods. It's like setters for our smart pointer because it's private. And now set ID. We're gonna have int ID and let ID get ID equals to ID. As you remember, get method just gets the row pointer. And here we can call set ID. But let's make the same with the string, with name, with string. And I will show you where we made a mistake. Qstring, sorry, string name get name equals to name. Okay. And here, as I said before, when data is changing, the touch method should be called. QSharedDataPointer makes it for us, but in this case we have to call it manually. So after we change something, we have to detach, call it method. So if two objects sharing the same object, copy gonna be made. Also we can make quickly getters. So ID, it's constant method D ID. Also the same with name, but here is QString. And so D name. And also we can make the copy constructor for it. Employee and everything that we should copy is just a smart pointer. Then let's go to the main CPP and test it out, and I will explain you a bit more about what I done. Not employee data, just employee. And let's hide it and make E3 example number 3. So qdebug. Let's make messages just to know where we at. Creating employees emp1, and we actually created ID, I don't know, 1, 2, 3, and name John. Then qdebug, copy emp1 to emp2. Debug, and here we copy the same data, and then I want to modify it and show what will happen. So we modify emp1 and let's set E1 set name to the, I don't know, Bob. And notice here that those shared pointers are mostly used for internal implementation of implicitly shared classes. So what I mean by that, the most frequent use case where you use shared smart pointers, it's like how I done it here. I create one with the one class with the data, and then one class with the smart pointer, and like for internal implementation. As you see, we manually call detach, and if we don't, then the object wasn't copied, and we will see only one message from the structure. Let me show it. So here, oh, no, I forgot to call E3. As you see, we have two messages where when it's destroyed. So that means we have two objects, not one, and it was copied. So creating emp1, then it is created, it's a message from the constructor, then copying is, then we modify. So we write employee data is copied when we set name. So when we set name, here see the detach. So the so data was copied, object was copied, and then we get this message for the destruction 2 times. And if we change for and just so you see, for example, let's comment this when I call detach methods, what will happen? You see, only one time it is destroyed, and so it is not really shared data pointer because we didn't call it. So explicitly tells us that we explicitly should call detach method, and if you want to remove it and not use that, you can just use QSharedDataPointer, and it will work the same way. You can run and it's all good. You see two messages. But the important thing is that if you want to share functionality, functionality to work properly, you must call this get method. Okay, not forgot to use it when you change some data. The next pointers we will look at, just let me hide it, are QPointer and QWeakPointer. And names are not very fancy, so those are going to be easier. The first one is QPointer. Let's include it, QPointer. And even though we will only take a look at functionality and the most frequent use case, I think you should know that Qt in previous versions deprecated QPointer, then let everybody switch to QWeakPointer, then they removed Q object tracking capability from QWeakPointer, so we have to use QPointer. Okay, enough crying. Let this the main purpose of the QPointer is a weak reference to a Q object. It automatically sets itself to null PTR if the Q object points to is destroyed. In simple words, we can only make a pointer to Q object, inherited object, and we have to delete it before the point because the pointer is weak. But you'll probably ask, like, I mean, delete. Okay, just if my token is not enough explainable, you can only create. You can only point to the. I'll create Q object, my Q object like this, to Q object inherited object. And you also gonna need to write this delete thing and at the end. But why we use it? It does why if it exists if not give us garbage collection. And the thing is, pure pointers after deletion become dangling ones. So after deletion, we want it to be null PTR, and QPointer just help us with doing this. Let me show you an example, and you will understand what I mean. So let's say public, as in previous examples. Okay, let me copy it because it will be similar. Just I will change this, and it inherits QObject. And I create its yes, example 4, and call it, just not forget later. Here, let's say we create QPointer to my QObject. obj new my object, and this okay, we can also yeah, let's quickly create change this constructor to pass, not take another line. Just like this. Let's say ABC. Then we create the second object, second pointer. That's obj2 to obj just. Then we can QDebug to see that obj get a, they are the same. It's like the same object. They also sharing it. And if you write here obj get a equals to, I don't know, some other things, some text, then and then QDebug all of this, you will see that it's also one object. And at the end, you should always write delete obj. For now, just let's run it. As you see, it's the same one object. And we delete it because, and why we use it, just why we use QPointer instead of raw pointers? Because when we write delete, obj is not dangling pointer, it's null PTR, and it's good. Like, you don't have to write obj equals to null PTR like with raw pointers, and then we can check it. So we have a method called isNull, and let's QDebug also. And if it is null, then let's write obj null PTR, and then the same with the second, not obj. Let's run and check. Yes, it is null PTR, and that is good. And if we remove deletion of object, memory will become leaked. So as I said, just do not make them dangling. The next one is QWeakPointer. Here we see I go with list QPointer, QWeakPointer, then gonna be scoped, but doesn't matter. QWeakPointer is a weak reference to an object managed by QSharedPointer. Its main purpose is to observe an object without owning it. Let's say you have a shared object managed by QSharedPointer. You have that one object with this pointer. And multiple parts of your code might share ownership of the object. Like here you have this pointer, here, in different parts of program. And it can create a circular reference. For example, an object holding a QSharedPointer to another object that also holds a QSharedPointer back to the first. You understand? Like then it becomes circular, 1 to 1, just. And the reference count will never drop to 0, and the objects won't be deleted, even when they should. To solve this problem, we have QWeakPointer that can be used to break the circular dependency. It observes the object without increasing its reference count, allowing proper cleanup when the time comes. So if I want to draw it, let's paint. Here I have one shared pointer, here I have another. And like they can make circular dependency. With the weak pointer I can break it and all objects gonna be deleted instead of making memory leaks. Let's write example for this. Now I will not use some additional classes, just with the integer. It will be easier. So void e5. Let's make your shared pointer with integer sharedPTR is equals to QSharedPointer with integer create, and just it's instead of calling constructor, we can do it like this. And then let's create QWeakPointer, also int weakPTR is equals to sharedPTR. Then we can check, just as in previous example, if weakPTR is null. And let's qdebug. The object is still alive. Then when we make sharedPTR clear, let's check, sorry, Q, like this. Has been deleted. And let's call it. And everything works properly just as we expect. When we clear, it's deleted, like obvious, you know. But if we change QWeakPointer to the QSharedPointer, let's just try it. Here's what gonna happen. What? Why it is not deleted? And you can see that the object is not null PTR, and we left a dangling pointer, so we have problem. So in this case we can use QWeakPointer just to delete it properly. The only two smart pointers left to us are QScopedPointer and QScopedArrayPointer. They are like to each other and not so hard, so it will be quick. QScopedPointer provides us exclusive ownership of dynamically allocated objects. It means we cannot share access to the same object between many pointers. But the important thing I should mention is that Qt started to deprecate it to encourage us using unique PTR from the standard library. And let me show you what I mean in code. Hide the previous. And let's go E6. Here I want to include it quickly. QScopedPointer and also QScopedPointer array, because I will use it in the next example. So QScopedPointer of my object, let's just use that first object we create, just empty, not inherited from anything. Have prints the, output to the console statements. Yes. And we create ptr new my object with some text inside abc. My object. No matching. What? Oh yeah, sorry. Let's just create one more. Probably I forgot to edit. Just like this. And it will work. Okay, and as you see, if we run, we create and then destroy, as expected. But what if we want to move ownership to other pointer? Because, you know, if we want to like write ptr2 equals to ptr, ptr, then call to delete the constructor. We can do that. The purpose of that pointer is that we can't share the ownership. I mean, we can, but we can. But if we want to move to the other pointer, like we can do it probably, yeah. And we should use ptr. Let's here ptr take method. If I do it, it will work, of course. Here ptr. Oh, sorry. It's like here, like this. Because take method, if you search here, take scope, where? Oh, probably we don't even have it because I'll show you why. As you see, take is deprecated. Use instead, use unique ptr with the call and release instead. And I don't know, if a few days it worked, but for now, let me check. ptr, it's like, and then if I want to delete it, I'm just curious if it will work, because it should, even though it's deprecated, but should work. Yes, it worked. Okay. And to not get warnings, we have to use unique ptr from the standard library. So unique no, it's not, header called memory. Yeah, my bad. Header is called my memory. And here we can change to std. Unique ptr, my object, create, and then call the release. As warning suggested, release us. Yes. And if we run it, it will work. I know it may seem strange because Qt is a framework and why should we use standard library tools, but they want us to use more modern tools. And similar rules applied to the next smart pointer, specifically QScopedArrayPointer. The difference between those two is that QScopedArrayPointer manages array and accordingly deletes a full array at the end. So we can write void e7 7 example. Here let's create QScopedArray ScopedArrayPointer to the main my object. Let's call it array new and create with the line of 5. Let's assign some values to a. So int t equals to 1 minus 5 plus plus a time equals to, a. It's the text inside equals to, let's say, obj number, and we can use static method from QString. We'll talk about QString in depth in just just next episode. So you have to watch it, and we'll talk about all methods inside. So Q number on I, this we assign this text, and then I want to print it. So QDebug array I. Sorry, R. Like this. And if I want to take it, I will get deprecated warning. Like the same way I done it before. I even can copy str2, let's say like this, take, like the same way it was before. Maybe let's name it just R2 or row. Yeah. And here print it. And then of course delete. Delete all array. You see, it will work, but with warning. So to avoid it, we can use std unique pointer. Then here we need to use get method, because unique pointer don't have overloaded square brackets operator, and here leaves like this. Yes, unique pointer doesn't have additional class for arrays, so we have to use get method before searching in info index. And let's run, check how it works. Sorry, it's I didn't even call it. Okay, sorry. Now I called you can trust me. It will work with the take, but you're just gonna have a warning. And here, as you see, everything is destroyed without warnings. And okay, we covered all kinds of smart pointers, and I think this is it for today. I'm a bit tired. Thanks for watching, and see you in the next episode.